So this one is October-November 2020 paper for variant 1. The first part will discuss organic chemistry questions, and the second part will do the moles questions. Normally, the last of end of the paper, you will find organic chemistry questions. Okay. In this question, question number 6, ethane, propane, butane are members of a same homologous series. Name this homologous series, like what we call ethane, propane, butane, which series they belongs to. As you can see, the name is ending at ane. So which series methane, ethane, propane, butane belongs to? So they belongs to alkane. And state two ways member of a homologous series are similar. Like what are the characteristic of the homologous series? The characteristic of homologous series, they have the same general formula is there. They have a same chemical properties. That's how all the members are similar. They will have the same general formula. The whole series will have the same general formula, as well as they will have the same chemical properties. Like the way ethane react, that will be same as the way propane react. Yeah, they will have the same reactivity, same chemical property or same way they react. Like example, all alkanes undergo substitution reaction. So they will have the same reactivity, or simply you can say they will have the same chemical properties. In part B, it is related to moles part, but we can solve right now. In this question, they say 1 mole of a ethane. If we have 1 mole of ethane, it contains 6.02 exponent 23 molecules. How many moles are there? How many molecules are there in 15 gram of ethane? So first, we will find the moles of ethane. How to find the moles of ethane? If the mass is given, the formula is moles equal mass in gram. That's the first formula, that moles equals mass in gram divided by the molar mass. So mass in gram divided by molar mass will give us the moles. So here we have 15 grams of ethane. So we write 15. How to find the molar mass? For a molar mass, we have to use a periodic table. The molar mass is always by using a periodic table. So in a periodic table, we'll find the mass of a carbon. The mass of a carbon is 12. Multiply by how many carbon atoms are there? 2. So 12 multiplied by 2, 24. Plus mass of hydrogen is 1. And how many hydrogen atoms are there? 6. So it will be 24 plus 6. So that molar mass is equals to 30. So when we work out, the molar mass will be 30. So 15 divided by 30. So when 15 is divided by 30, how many moles of ethane we'll get? We'll get 0.5 moles of ethane. But in the question, they don't ask for moles, they ask for number of molecules. And they give you a relation here. They said that if we have 1 mole, it will have this many molecules. So whenever 1 mole of any substance, it will have this many particle. Avogadro's number 6.02 into 10 to the power 20. 3 molecules are there. So in the question, we have 0.5 moles. So if we have half mole or 0.5 moles, then how many molecules will be there? X. We cross multiply. So 0.5 multiplied by 6 exponent 23. So it will come out as 3.01 into 10 to the power 23 molecules. So the next part, in which propane react with a chlorine, write a formula of a product that does not contain carbon. Remember, whenever alkane react with a chlorine, it's a substitution reaction. What will the formula for prop-ane? Prop means 3 carbon, and because it's ane, so number of the hydrogen will be twice plus 2. So 3 multiplied by 2 is 6 plus 2, 8. So C3H8. So C3H8 are the number of the particles. C3H8 is the molecular formula. And if it reacted with a chlorine, chlorine is Cl2. Whenever alkane react with a chlorine, it is a substitution reaction. What happened in a substitution reaction? One atom enter, like one chlorine will enter, and one hydrogen will leave. So as a result, what will be the product? The product will be C3H7, and one chlorine is added, so Cl, plus hydrogen is removed, which combined with the other chlorine and produce HCl. So the product will be chloropropane and hydrogen chloride. The question is, write a formula for product that does not contain. So these are the products. Which product does not contain carbon? So HCl or hydrogen chloride does not contain carbon. So we have to write here HCl, because the question is, write a formula of the product which does not contain a carbon. So there are two products, one contain a carbon, one does not contain a carbon. So we have to write for the one which does not contain a carbon. Then draw a structure of an organic product and show all the atoms and all the bonds. So this is an organic product. Organic product means which contain carbon here. So this is the organic product. So we have to draw the structure of this organic product. And we have to represent all the bonds and all the atoms. So first 3 carbon atoms are there. And 1 chlorine is attached. We can attach with anywhere. And then remaining will be the hydrogen atoms. So this will have 2 hydrogen. This will also have 2 hydrogen. And this will have 3 hydrogen. So this is the structure of the product which is formed when propane react with chlorine. And name of the product, it is chloropropane. Chloro because of chlorine is attached. Prop because there are 3 carbon atoms, and ane, they all have a single bond. State the name of this type of reaction. So what we call this type of a reaction, we call that as substitution reaction. So remember, whenever alkane react with halogen chlorine, it will undergo substitution. If there was alkene, then the reaction will be addition reaction. In part D1, aqueous bromine was added to ethene. So whenever we add aqueous bromine, what is the color of aqueous bromine? Original color, it is orange. And whenever we add to alkene, any alkene, it is not necessary ethene, it can be any alkene, like it can be ethene, propene, butene. So whenever we add aqueous bromine to any of the alkene, what we'll observe? We'll observe that the starting color before the reaction is orange, then it decolorized, so the final color will be colorless, or there will be no color for the solution. So orange change to colorless gives an idea that the substance which is present is alkene and it undergo addition reaction. Explain in terms of bonding why there is no color change when aqueous bromine is added to ethane. So when, for example, if we have ethane, not ethene, if we have ethane or alkane, and when we add, we find there is no color change. So what is the reason why there is no color change when ethane is there? Because ethane does not contain the double bond, C double bonded C. And ethane, if does not contain C double bonded with C, so there is no reaction with bromine. It only undergo a color change if the reaction occur. If there is no reaction, then there will be no color change. So alkanes does not show any color change. Alkenes show the color change. Then the next part, we have alkane. You can see this is C4H10. Number of the hydrogen are twice plus 2, so this is alkane. And which alkane is this? Because 4 carbon atoms, so it will be but because of 4 carbon atom. And because it's an alkane, so it is butane. We want to draw the two isomer of butane. Remember, whenever we are drawing isomer of alkane, how to draw an isomer of alkane? First, we'll make a straight chain. When we want to draw the isomers of alkanes, how we draw these isomers of alkane? There are two ways to draw. First one, we draw the straight chain. And the second one, we will draw the branched one. And if we want to draw the isomer of alkene, so there are three ways to draw the isomers of alkene. We can change the position of double bond. We can draw the branch, or we can make a cyclic alkane. So one way, change position of double bond. Second is make a branched. And the third one, you can make a cyclic alkane. These are the three ways for alkenes and two ways to draw isomer of alkane. So in the question, because it is butane, so butane means, but means 4 carbon and ane means they all have a single bond. So it is an alkane. So we want to draw an isomer of alkane. So first what we can do, first one, we can draw the straight chain. And the second one, we can draw the branched. So if I want to draw straight, I will, and we have to show all the atoms and all the bond. So I will draw 4 carbon atoms in a straight line. And if I want to make a branch, so branch is always like it started with the second one. Second, third I can make, but not with the first one. So I can make a branch up or down. Then we have to represent all the bonds. So because these are alkanes, so between the carbon atoms, there should be a single bond. And then rest will be hydrogen. Carbon maximum can form 4 bonds. This is having 1. So this will have 3 hydrogen. This is having 2. So this will have 2 hydrogen. This is having 2. So 2 hydrogen. This is having 1. So 3 hydrogen. And the other one will have, the left-hand carbon will have 3. The central one will have 1 hydrogen. The right-hand carbon will have 1. And the branch carbon will also, right-hand carbon will have 3 hydrogen. And the branch will also have 3. And how to know whether you did, like you draw the structure correct? You have to count the number of carbon and hydrogen. When I count for this is C4 and 3, 4, 5, 6, 7, 8, 9, and 10. So C4H10 is a molecular formula for this compound. And same thing, this is C4. And how many hydrogen are there? 3, 6, 9, and plus 1, 10. So C4H10. So when two compounds have the same molecular formula and different structures, we call them as isomers. So whenever you want to draw an isomer of alkane, the way is make first one as a straight chain and the second one the branched. The next part, butane is formed when long chain hydrocarbon are cracked. Remember, whenever we do or carry out a cracking of a long chain hydrocarbon, what will be the products? The product will be alkane. One of the molecule will be alkane and the other molecule will be alkene. Complete the chemical equation to show other product when butane is formed by cracking. So butane is formed. So this one is alkane. C4H10 is alkane because the number of hydrogen are twice plus 2. So the other product of a cracking should be alkene. And total number on the left hand side should be equal to total number on the right hand side. C6 on the left hand side, 4 are used here. So how many are left? 2. And out of 14, 10 hydrogen are used in alkane. So remaining are 4. So C2H4, or it will be ethene as of other product. So whenever cracking is done, one of the product is alkane, another one is alkene. How to identify it's an alkene? The journal formula is CnH2n plus 2. And to be an alkene, the journal formula is CnH2n. Like the number of hydrogen will always be twice as compared to number of carbon atoms. The next one, finding the empirical and molecular formula. So how we find the empirical formula from percentages or the mass? There are three steps. Step 1 is divided by atomic mass. Step 2 is divided by the smallest value, and step So step 1 is divided by relative atomic mass. Step 2 is divided by the smallest value. And step 3 is make the simplest ratio in a whole number. So we have the percentages. The carbon is there. The hydrogen is there. In the question, the carbon is given 85.7 and hydrogen is 14.3. Step 1, divide by atomic mass. So we'll divide this by 12 and we'll divide this by 1. So 85.7 divided by 12, that will give 7.14. So this will be 7.14 and this will be 14.3. Now what about step 2? Step 2 is divide by the smallest value in the combination. So 7.14 is the smallest value. So I'll divide by 7.14 and this also 7.14. So when we divide by smallest value, this will be 1 and this is approximately 2. So the empirical formula is CH2. The second part, the molecular formula, the molecular mass of a compound is 112, that is given. We need the molecular formula. So the molecular formula equals empirical formula multiplied by n. So molecular formula is empirical formula times n or multiplied by n. What about the empirical formula? We already calculated, find the previous part, which was CH2. Then what about the value of n? How to get the value of n? N is equals to molecular mass of a compound divided by empirical mass. The molecular mass of a compound that is given, which is 112, that is given in the question. But how to get the empirical mass? Empirical mass, you will use a periodic table to get the empirical mass. Empirical mass of CH2. So carbon is 12 using a periodic table, and hydrogen is 1 and there are 2. So it will be 12 plus 2 makes 14. So the empirical mass is equal to 14. So C2 and CH2, the empirical mass is equal to 14. So 112 divided by 14, this will give us the value of n. So 112 divided by 18, divided by 14, this will give us 8. So value of n is equals to 8 here. So it is CH2 and the value of n is 8. So this 8 is multiplied with carbon and this 8 is multiplied with hydrogen. So when it is multiplied with both, the molecular formula which represent the actual number of atoms, so it will be C8 and H8 multiplied by 2, 16. So C8H16 will be the molecular formula. The next question is also related to organic chemistry. So see the first question of 16 marks, then the next question is of 8 marks. So about 24 marks are totally based on organic chemistry out of 80. In question 7, ethanol can be manufactured by 2 different ways. One is called fermentation of a sugar. Another one is ethene react with steam. As we already discussed, there are some advantages and disadvantages of these method of manufacturing alcohol. So give one advantage of using fermentation compared to the method 2. So the one advantage, the raw material which we are using are renewable or sustainable, we can also say, or it does not, like, it is a cheap process to prepare alcohol. So renewable raw materials are there, or sustainable raw materials are there, because you can grow the plant and obtain this sugar and you can use it to manufacture alcohol. One disadvantage of using fermentation, so fermentation is a very slow process and it is also a batch process. Batch process means like reaction will start and then stop, then start, then stop, like many times start and stop. And another disadvantage, we have to write only one of the disadvantage. Another one, we have to purify the product, because this does not give 100% alcohol. So it will, will have a sugar solution, a sugar dissolved in water, so sugar solution. So water is also there, and when sugar solution convert into alcohol, so there will be alcohol as well, like sugar converting to alcohol. So then we have to separate water and alcohol from each other. So fractional distillation must be done to separate the two miscible liquids. So purification of the product is also should be done. But here, what happens when ethene react with steam, it will produce ethanol, and we don't have to purify, as only one of the product is there. There is not mixed with any other substance. So you have to learn these advantages and disadvantages of fermentation and manufacturing alcohol by reaction of alkene with steam. Part B, ethanol or alcohol react with acidified potassium manganate. What is this acidified potassium manganate? It is an oxidizing agent. Oxidizing agent means help in oxidation to form water and the product that turn. So ethanol react with acidified potassium manganate to form water and the product. So remember, whenever alcohol is oxidized, whenever we have alcohol and we use an oxidizing agent, potassium manganate 7, it will convert alcohol into carboxylic acid. So oxidation of alcohol result in a formation of carboxylic acid. So state the name of a product that turn the litmus red. So the litmus turn red means it is acidic substance, and which acid will be produced? If we have ethanol, it will produce ethanoic acid. If it was propanol, it will produce propanoic acid. So the product which convert this litmus red, that is ethanoic acid. So oxidation of alcohol result in a formation of carboxylic acid, and you have to learn the name of this oxidizing agent, acidified potassium manganate 7. State the type of a reaction that ethanol undergo when acidified potassium manganate 7 is added. So, or react, so that is known as oxidation. Because oxidation of alcohol produce carboxylic acid. In part C, ethanol react with methanoic acid. So remember, whenever alcohol mix with acid, carboxylic acid, it will form an ester. The first name of ester is always from alcohol and it should contain YL. And the second name of the ester is from carboxylic acid, so it should have O8. So name the ester form. So first name is from alcohol, so it will be eth, because alcohol is ethanol, so it will be eth, and YL, ethyl. And the second name is from carboxylic acid, so methanoic acid, so it will be meth, and the part which is coming from carboxylic acid should have O8, so it is ethyl methanoate. So first name is always from alcohol and the second name is from carboxylic acid. Then we have to draw the structure of ester and show all the bonds. So C double bonded with O. The part which is attached with oxygen, we name first. This is the part we name first, and the part which is attached with the carbon, we name second. So ethyl, eth means 2 carbon, so we have to draw 2 carbon. 1, 2. Methanoid, meth means one carbon, so one carbon is already there, so we don't have to attach any carbon. Because it is meth, meth means one carbon, eth means two carbon. So two carbons are attached with oxygen and one, there's no other carbon attached with C double bonded with O. Then we will draw remaining hydrogen. This will have two hydrogen atoms. This will have three hydrogen. So this is the structure of ethyl methanoid. Eth because of two carbon, and this part is always from alcohol. We named it YL, and the part which is attached with C double bonded with O should always write at O8. We name second and O8. So it is ethyl methanoid. So depending on the acid and alcohol mixed with each other, that will form a specific ester. The first name is always from alcohol and the second name is from carboxylic acid. The last part, the table shows melting point of ethanol and sodium chloride. This is related to bonding and structure. Ethanol, it's a covalent compound, so it will have a weak force of attraction. Sodium chloride is an ionic compound, so it will have a strong force of attraction. That's why you can see the melting point is low. Here the melting point is high. The difference in the melting point is due to attractive forces between the particles. Name the type of attractive force in each substance which is responsible for difference in the melting point. So ethanol, there will be a force between the molecules, and sodium chloride, there will be a force between the ions. So type of attractive force, that will be called as a weak intermolecular force. Between the molecules. And sodium chloride is an ionic compound, so strong electrostatic attraction between the ions. But this part is related to bonding and structure. So this was about organic chemistry question from October-November 2020 paper.